let's put the second derivative into action. Going back to example 12, which you viewed that video a little while ago, and we were able to prove in example 12 that that function that was given to you had a relative max at x equals -3. Okay. Well, now that we know that, let's show that we could get the -3 as a relative max also using the second derivative test. All right, so we already know what the answer is, but let's show how the second derivative test can produce that same answer. Okay. Well, here's our first function, x squared minus 3 times e to the x. And then here's our first derivative. Now, again, just like before, we're interested in figuring out when the first derivative is equal to 0. And we did this work already. We know that this happens at x equals -3 and 1. I don't need to rehash that algebra. You can go back and look if need be. But these are our two critical points. Now, we're not going to put them on a number line this time. Okay? All we're going to do is just plug the critical points into the second derivative and let the second derivative guide us, and the second derivative test guide us to our solution. But the thing is, we need the second derivative. So let's get that. So we need f double prime of x. Right? Once again, we're going to have to use the product rule. All right, so derive the first, e to the x derives to itself. Keep the second, x squared plus 2x minus 3 stays the same. Plus, now we keep the first, we keep the e to the x, and we derive the second. So we have 2x plus 2. There's our second derivative. Now what are we going to do? We're going to plug our critical points in. In this case, we're just going to plug in the -3 because the purpose of the problem is to show that their function has a relative max at x equals -3. We're going to plug -3 into the second derivative, and we're going to check out the sign of our answer. So let's do that. When we plug -3 in, so we want f double prime of -3, that's e to the -3 times -3 squared plus 2 times -3 minus 3 plus e to the -3 times 2 times -3 plus 2. It's a lot of numbers there, so let's simplify this out. -3 squared, that's 9, correct? 9 minus 6 minus 3, 0. So this whole thing right here at the very beginning goes to 0. 0 times anything is 0, so it doesn't matter about that part. Plus, we have our e to the -3 again. And then we have 2 times -3, which is -6, plus 2. So that's -4. All right. So this is our f double prime of -3. What's going on here? We have 0 plus this term. Well, this is e to the -3. But we know what about e? Always positive. So even though our brain might think, oh, this has to be a negative number, no, e to the -3 is a number that's pretty close to 0. It's positive though. So we have a positive value times -4. What's a positive times a negative? It's a negative, yes. So this value right here is some messy decimal. I don't really care about it. All I care about is the fact that that decimal is less than 0. Because I've got a positive times a negative. That's a negative, and a negative is less than 0. So I've got a negative second derivative at x equals -3, and the first derivative is equal to 0, so my second derivative test comes into play. If I've got f prime of -3 equals 0, f double prime of -3 is less than 0, therefore f has a relative max at x equals -3. Okay, by the second derivative test. Okay, so I've drawn my conclusion and I've written that down along with the supporting statement. You can use the second derivative test if you prefer on the exam. You will not be required to use it.